Hello everyone, welcome to Unify Chem Study channel. So in this particular video, I am going to discuss about one of the most important reducing agent. The name of this reducing agent is called DIBAL H, and the full name is diisobutyl aluminium hydride. So this is the structure, as you can see, where 2-isobutyl group is directly bonded with this aluminium and one of the hydrogen is directly attached with aluminium. So how would you prepare this particular reducing agent? So the method is, if you take this alkene and try to reduce it in presence of hydrogen gas and aluminium, and then initially it gives this tri-isobutyl aluminium. So further, if you heat it at 140 degree centigrade temperature, then it gives the desired product, as you can see. Now if we talk about the structure, so this particular compound exists as a dimeric form like diborane. Okay, so here you can see that aluminium is directly bonded with 2-isobutyl group, and in between these two aluminium there is a bridging bond is there, okay, like diborane. And the main important properties of this compound is it can act as a reducing agent. So now coming to the examples, what type of functional groups it reduces? So if we talk about the reduction of ester, reduction of cyanide, reduction of amide and all, as you can see in this particular example. So if you take ester compound and do the reaction by using DIBAL, so it gives corresponding aldehyde, okay. But at the same time, this particular reaction is basically depends on different other factors as well. Like if you try to use the polar solvent during the reaction, then it gives directly alcohol product. Now if you look at the other compound like cyanide, so this is the general structure of cyanide. If you do the reaction in presence of DIBAL, so it gives corresponding aldehyde. Now if you take amide, then this particular compounds it gives corresponding amine. So further this trimethyl silylated ester, so it gives corresponding aldehyde. So the beauty of this particular reaction, if we talk about the reduction of ester compound, as you can see here, that DIBAL reduces ester and produces the tetrahedral intermediate. So this is the tetrahedral intermediate A, which may be stable at low temperature. As you can see, temperature is mentioned here near about -78 degrees centigrade. So during the aqueous workup, this intermediate collapses and it gives the aldehyde product. So this is the overall mechanism. As you can see, this particular reaction is basically takes place in presence of hexane medium at very low temperature. So this is the overall intermediate. As you can see that this DIBAL hydrogen, so it is, if you draw like this, so this particular hydrogen, it can acts over there and it is open up. Now as a result, it gives this kind of intermediate, tetrahedral intermediate, and further acidic workup, it gives the corresponding aldehyde product. Now so here as a solvent, basically hexane is used. As you know that it is a non-polar solvent. Now if you try to use the polar solvent, then what would be the result? As you can see, so if you try to use polar solvent, so this particular tetrahedral intermediate A, as you can see here, and it decomposes faster than it is generated. So with the formation of aldehyde, the solvent effect is explained like this. Okay.